Hello students, in this session we are going to discuss System of Particles chapter NEET previous year questions. So from that we are going to discuss previous year questions of NEET from this chapter from two topics. So one is center of mass concept, the other one is motion of center of mass concept. So out of which the first question in center of mass concept is two objects of mass 10 kg and 20 kg respectively are connected to the two ends of a rigid rod of length 10 meter with a negligible mass. The distance of the center of mass of the system from the 10 kg mass is. So here they have stated that two bodies of masses 10 kg and 20 kg are connected to a light rod, a light rigid rod. So here they have given information that mass of the rod is negligible. Say for example, this is body of mass 10 kg and this is body of mass 20 kg. So these two are connected by a rigid rod. So what is the length of the rod is given? The length of the rod given is 10 meter. So they have asked to calculate distance of center of mass from 10 kg body. See here, one thing you have to understand, that is the distance of center of mass is close to the a big body, or you can say large sized body, or you can say the body which is having more mass is 20 kg in this question. So the center of mass is close to the greater mass. So center of mass is close to this particular 20 kg mass. Now let us consider the center of mass is located at a distance x centimeter from 10 kg body. Now we have to calculate center of mass position from 10 kg block. Here while we are calculating position of center of mass, it is very clear that the algebraic sum of moments of mass is always 0. The algebraic sum of moments of mass is always 0. So this is the keyword in solving all the questions related to the calculation of position of center of mass of system of particles. See here, 10 kg block is producing anti-clockwise moment. See, because of the 10 kg weight, so it is able to turn it in anti-clockwise direction, and the 20 kg mass provides clockwise moment. So here it's very simple that the principle of moments m1 x1 plus m2 x2 is equals to 0. m1 is 10 kg and its position is x, and this 10 kg block is providing the anti-clockwise moment. So the anti-clockwise moment is positive, and 20 kg block is providing the clockwise moment. So the clockwise moment is negative. So 20 into what is x2? x2 is position of center of mass from 20 kg body, that is 10 minus x. So this value is 10 minus x is equals to 0. So 10x is equals to 200. So when you send it to other side, it will be like 200 minus 20x. Send it to this side. 10 plus 20, 30x is equals to 200. 0 cancel. The position of center of mass from 10 kg block is 20 by 3 meter. So this is what position of center of mass from 10 kg block. So the here keyword is, we can utilize this logic that the algebraic sum of the moments of mass is always 0. So option number 1 is suitable. Then next move on to the second question. So the question here is, there are two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from 5 kg particle is nearly at a distance of. See, in 2020 as well as 2023, so the model of the question is exactly same. So according to the previous question model, you can find that distance as, so here at last you got the calculation that, see here, according to principle of moments, m1 x1 is equals to m2 x2. m1 is 5 kg into x. What is m2 here? The mass of the other body is 10 kg into what is the distance? 1 minus x. So as a result, 5x is equals to 10 minus 10x, 15x is equals to 10. So x is equals to 2 by 3 meter, so which is equals to 0.67 meter nearly, and this will be equals to 67 centimeter. So option number 3 is suitable. So pause the video and then analyze the solution. So the more clarity is given in the previous question explanation. Let's move on to the next question. See students, in this question they have given three masses which are placed on the x-axis. So where 300 gram is placed at origin, 500 gram is placed at x is equals to 40 centimeter, and 400 gram body is placed at x is equals to 70 centimeter, and they are asking the distance of center of mass from the origin. So this is like one of the routine question. It's like a calculation based only. So let us draw coordinate system. On this coordinate system, at origin, first body of mass 300 gram is placed, and at a distance, at a position 40 centimeter, another body of mass 500 gram is placed. At a position 70 centimeter, third body, that is 400 gram body, is placed. So while we are calculating the position of center of mass, so we have to check whether there is only one coordinate or there are two coordinates or three. So according to this question, the particles are placed along x-axis. So it means there is no position of center of mass along y-axis and z-axis. It is like ycm and zcm is 0 only. So we simply calculate xcm, position of center of mass along x-axis, that is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. See students, what is the position of first particle, 300 gram particle, is at origin. So that's like origin plus m2 is 500 gram into x2 is 40 centimeter. As the options are in CGS system, I am going to take the data in CGS system only. So 500 into 40 plus 400 into what is the position of the third particle, 70, by what is the total mass, 300, 500, 800 grams, and 400, total 1200 grams. So then xcm is equals to, so here it is 20,000 plus here it is 28,000 divided by 1200. So two zeros will cancel, which will be 480 by 12. So 40 centimeter is the position of center of mass. So here the position of center of mass is 40 centimeter. Option 1 is suitable. Next, let's move on to the fourth question. Consider a system of two particles having masses m1 and m2. If the particles of the mass m1 is pushed towards the center of mass of particles through a distance d, by what distance would be particle of mass m2 move so as to keep the center of mass of the particles at the original position only? This is original position. So in the question they are saying that to keep the particle at the original position, if particle of mass m1 is moved a distance d towards center of mass, then what is the distance moved by the second particle to keep the center of mass there only? Let us imagine center of mass is at a distance x from the m1 body. See, this is position of center of mass. Now from m1 it is at some distance, and from m2 the distance between the two particles minus this distance from m1. Now this m1 is moving, or it is shifted towards the center of mass. So to keep the center of mass there only, in which direction we have to move m2? M2 must be moved towards the center of mass only. So in this case also we use the logic that the algebraic sum of the moments of masses about the center of mass is 0, or you can balance both of them. So here m1 provides anti-clockwise moment, m2 provides clockwise moment. So let the distance moved by m2 is x. Then according to the vector sum of the principle of moments about the center of mass is 0. So you can write m1d is equals to m2x. Required x is equals to m1 by m2 into d. So to do not change the center of mass position, m2 should move this much distance towards left, that is towards the center of mass. So the suitable option is option number 2 is suitable. Okay students, let's move on to the next question. So here they are giving two bodies, each of mass 1 kg and 3 kg respectively, and their position vectors they have given, and they are asking to calculate the center of mass of the system. See, center of mass of the system if they give in vector notation, so we can write RCM is equals to m1 r1 bar plus m2 r2 bar by m1 plus m2. So RCM bar is equals to m1 is 1, so that I cap plus 2j cap plus k cap, plus m2 is 3 into minus 3I cap minus 2j cap plus k cap divided by what is the total mass? 1 plus 3 4 kg. So I cap plus 2j cap plus k cap minus 9I cap minus 6j cap plus 3k cap by 4. So then 1 minus 9 minus 8I cap, 2 minus 6 minus 4j cap, 1 plus 3 4k cap by 4. When you take 4 common and if you divide with 4, 4 cancel, minus 2I cap minus j cap plus k cap. So this is the suitable answer. This is what the position of center of mass. So the suitable option is first option. Right students? Next question regarding the calculation of position of center of mass is, here figure shows a composite system of two uniform rods of lengths as indicated. Then the coordinates of the center of mass of the system of rods are. So here they have given two rods, and they are saying the two rods are of uniform, and they are giving length of one rod as L, length of the other rod as 2L. So these two rods are said to be uniform. So linear mass density lambda, linear mass density lambda is nothing but mass per unit length. So mass is directly proportional to length if they have uniform density. So that what we can say here is, we can say if mass of the rod of length L is m, mass of the rod of length 2L must be 2m. Why? Because they mentioned uniform rods and they are saying length as different. So that is why we can analyze masses. So let mass of rod of length L as m, then mass of rod of length 2L is 2m. Now they asked to calculate position of center of mass. So position center of mass xcm is equals to m1x1 plus m2x2 by m1 plus m2. See students, what is the position center of mass of the first body? L by 2, no? L by 2, because that is uniform body. So for that the position of center of mass is at midpoint. So that is at L by 2. So m1 is m, L is L by 2 plus position center of mass of the second body along the x-axis is 0. So it is placed vertically at the origin. So x coordinate will be 0. So that it will be 0 divided by total mass is m plus 2m, 3m. So m cancel. You will be getting x coordinate of center of mass as L by 6. Similar way you can find y coordinate of center of mass, that is m1 y1 plus m2 y2 by m1 plus m2. What is the y coordinate of first rod which is placed horizontally? It is placed along horizontal direction, so that is why its y coordinate of center of mass is 0. So that is equals to 0 plus m2 is 2m into what is the y coordinate of center of mass of the rod of length 2L at midpoint, no? So 2L by L, that will be L divided by total mass is 3m. So m cancel, you will be getting 2L by 3. So the position of center of mass in terms of coordinates xcm comma ycm is equals to L by 6 comma 2L by 3. Right students? So L by 6 comma 2L by 3, here third option is suitable. Now let's move on to the previous year NEET questions of motion of center of mass concept. Look at this question students. They are saying that two persons of masses 55 kg and 65 kg respectively are at the opposite ends of a boat. Say if this is a boat, so here is one person, here is another person standing the other end of the boat. Now the length of the boat is 3 meter and boat weight is 100 kg weight. Now they are saying 55 kg man walks up to the 65 kg man if the and sits with him. So the person who is having 55 kg moving towards the person of 65 kg, and now both are sitting at this end only. And then if the boat is in still water, then the center of mass of the system shifts by. Here they are asking us to calculate shift in center of mass. So change in position of center of mass is due to only external forces. When you look at the given situation, they are saying that the person is moving from one end of the boat to the other end of the boat. So it is very clear that there is no external force acting on the system of boat plus the two persons. So the forces involved here are internal forces. Internal forces cannot shift the center of mass. So Shift in center of mass is 0. On to the next question, students. A man of mass 50 kg is standing in a gravity free space at a height of 10 meter above the floor. He throws a stone of mass 0.5 kg mass downwards with a speed of 2 meter per second. When the stone reaches the floor, the distance of the man above the floor is. This question also can be solved with the help of principle of moments. See, here is a person who thrown stone downwards with a speed 2 meter per second. Mass of the stone is 0.5 kg. Mass of the person is given as 50 kg. So the instant when the stone reaches the floor, which means the stone has covered 10 meter. So according to principle of moments, m1 x1 is equals to m2 x2. So the distance moved by the stone is 10 meter, mass of the stone is 0.5 is equals to mass of the person is 50 kg and the distance moved by the person x2. So 0 0 cancel. So x2 is equals to 0.1 meter. But in the question they have not asked to calculate distance moved by the person. They asked to calculate position of the person at that instant. So the position of the person at this instant from the floor is 10 plus 0.1, that is 10.1 meter. Right, students? Now let's move on to the another question. Here the question is, a circular disc of radius r has uniform thickness. A circular hole of diameter equal to radius of the disc has been cut out as shown in the figure. So they have taken that circular portion of the disc of diameter r from one corner of the given disc. Now they are asking the distance of center of mass of the remaining disc from O. So indirectly they are asking to calculate the shift in center of mass. This is the original disc. So from this original disc, they have removed this is center of mass, original center of mass of the disc, and they have removed a circular portion which is having radius r by 2. Okay, students, now here the radius of the original disc is capital R. We have to calculate shift in center of mass here. We can approach this in two different ways. One is the shift in center of mass is equals to minus removed mass into distance by mass of the remaining disc. Or another method is shift in center of mass is equals to a1 x1 minus a2 x2 by a1 minus a2. As the mass is removed, I am taking minus. If they say mass is added, we have to take plus. And next point is, say we can solve it with the help of both the methods. Whatever the method is convenient to you, you can follow. See, when you look at it, this situation carefully, this is also similar to principle of moments. The moment of mass of the original as well as moment of mass of the removed part. So those two we can equate. See, mass remaining into shift in center of mass is equals to removed mass into the distance between the two center of mass. Here the meaning of x is distance between the center of mass of the original disk and center of mass of the removed disk. According to this diagram, distance x is r by 2. This distance is x value. Right, students? This is also based on algebraic sum of moments of mass is equals to 0 about the center of mass. And next point here is, here they used a terminology of disk. Disk is a two-dimensional body. So for the case of two-dimensional body, mass of the body is directly proportional to area. Original area is pi r square. Area of the removed part is pi r square by 4. So according to that logic, if m1 is m, what is the mass of the removed part? M by 4. So m by 4 is removed part mass. Now shift in center of mass is equals to minus, what is the removed mass? M by 4 into what is the distance between center of mass of the original disk and the center of mass of the removed disk, that is r by 2, divided by remaining mass is 3m by 4. Here m by 4 term cancel, so remaining value is minus r by 6, which is nothing but it shifts a distance r by 6 right side. Why it shifts right side? Center of mass always towards the more mass. So when this mass is removed, it shifts towards right side. Okay, students. So in case if the mass removed is right side, it will shift left side. This is what you have to understand. Now you can approach it with the help of this formula as well. So what is the position center of mass of the original sphere? That is at origin only, no? 0. So when you take a coordinate system, so this is at origin, center of mass of the original disk. Now center of mass of this disk is r by 2. So 0 minus area of the removed part is pi r square by 4 into its position is r by 2. So divided by, that is minus r by 2, no? So you can use the symbols. A1 minus A2, that is 3 pi r square by 4. Pi r square by 4 cancel, r by 6 you will be getting. So both the cases you will be getting the same result. The only thing is you have to understand whether the body is linear or the body is two-dimensional or the body is three-dimensional. Based on that you can understand the calculations. Right, students?